So question 131, we've got these trigonometric identities, sometimes called the addition formulae, sometimes called the compound angle formulae. So the first thing I'm going to do is to draw a large version of this diagram. Always a good idea to have a large, clear diagram. So then I'm looking to see what this side labeled X is. So using the big triangle, I can see that the sine of this angle, the sine of B, equals X over 1. So X is sine B. And let's find out what this side is. Again, using the big triangle with this angle here, cos B equals X over 1. So X is cos B. Then we look at this side. Looking at the bottom triangle, then this angle, sine of A is X over cos B. Sine A is X over cos B. So X will be sine A times cos B. The next side, again using the bottom triangle with this angle here, cos A equals X over cos B. So that means that X is cos A times cos B. Now I draw a couple of lines. So the question is, what is this angle here? It's going to help me to find out what this angle here is. Now if I know that these two angles are opposite each other, then they must be equal. Now this angle here is part of this right angle triangle. So this angle is 90 minus A, which means that this angle is 90 minus A. And looking at this triangle now, that tells me that that angle must be A. Okay, so now I can start looking at this small triangle here. So looking at this small triangle, we want to find the length of this side. So using trigonometry, sine A equals question mark over sine B. So the missing side is sine A times sine B. And then for this side here, cos A equals question mark over sine B. So the missing side there is sine A times cos B, or cos A times sine B. Okay, so let's have a look at this big triangle now here, which has got the compound angle here, A plus B. So the sine of A plus B is the length of the opposite side, which is sine A cos B plus cos A sine B. And that's divided by the hypotenuse, which is 1. So sine of A plus B is sine A cos B plus cos A sine B. So what about cos of A plus B now? That is the length of this side divided by 1. Well, the length of that side, cos A cos B, is the length of that there. And we have to subtract from that this, which is the same as that. So cos of A plus B is cos A cos B minus sine A sine B. So there we are. Those are the first two parts of the questions. So we've used the diagram to prove that sine of A plus B is that, and we've got a similar result for cos of A plus B. Let's write those down again. And we're going to use these two results now in part C to prove a similar result for tan of A plus B. So tan of A plus B is going to be the same as cos of A plus B over sine of A plus B. So let's see what that looks like. So we've got to try to get a result for tan of A plus B, which is that, in terms of tan A and tan B. But we've got sine A's and cos B's here. Now, because tan is sine divided by cos, I think it's going to be helpful to divide by cos. But we've got to divide by cos B and also cos A as well to get tans on the numerator. And we'll worry about the denominator in a moment. So let's divide both the top and the bottom, the numerator and the denominator, by cos A times cos B. So that gives us this, which looks horrendous. But the left-hand side, tan of A plus B, if we look at this first, we've taken this first term here and divided that by cos A cos B, and we see that the cos B's cancel out, leaving sine A over cos A. So that would be tan A. When we look at the second term, the cos A's cancel out, leaving sine B over cos B. So that's tan B. So that's our objective there, to have tan on the numerator. What's happened to the denominator? Well, cos A, look, the cos A's are cancel and the cos B's cancel. So this is just 1. And then we've got sine A over cos A is tan A times sine B over cos B, which is tan B. So a rather beautiful looking result now, certainly a lot better looking than the original expression. Tan of A plus B is tan A plus tan B over 1 minus tan A tan B. A rather smart little there, I hope you'll agree. So that's the end of that question. That's how to prove the compound angle formulae or addition formulae, call them whichever you want.